I've heard a lot about the Osprey in the news. What is it and how does it fly?
The Osprey is a tilt-rotor. It is a revolutionary aircraft that combines the best elements of both a conventional helicopter and an airplane. Think of it as an airplane that can take off and land like a helicopter.
Like a transport airplane, the Osprey has a fuselage, a wing, and a tail. As you can see, what makes the Osprey different is the two large prop rotors and the engine nacelles attached to the end of each wing. Like a tandem rotor helicopter, these two rotors are turned by a common drivetrain powered by both engines, and they spin in opposite directions above the aircraft. As the pilot adds power to lift the aircraft off the ground, the spinning prop rotors lift the entire aircraft into a hover. At this point, like a typical helicopter, the rotors are producing all the lift, with the wings producing only a minimal amount. Like a helicopter, the pilot can then direct this lift in a similar manner to how a helicopter flies. Once in forward flight, airspeed increases as the nacelles and rotor blades rotate evenly and smoothly from the vertical position, 90 degrees, to the horizontal position, or 0 degrees, until they are essentially large propellers, similar to a turboprop airplane. As airspeed increases during the transition from helicopter to airplane mode, the wing begins to produce more lift. And as the tilting nacelles and rotors move evenly and forward, they produce less lift and more thrust. Once the nacelles and rotors are fully in the horizontal, or airplane mode position, they serve as propellers, making the aircraft go forward, and the wing is producing all the lift. At this point, the Osprey flies and handles like a conventional airplane, with twice the speed, 2.5 times the maximum altitude, 3 times the payload, and 6 times the range of a conventional helicopter. When the pilot wants to land, they decrease power to slow the aircraft down. As the aircraft slows, the rotors and nacelles are smoothly and evenly moved from 0 degrees, or the horizontal position, back towards 90 degrees, or the vertical position, where they are again like the rotors on a helicopter. Where a normal airplane would stall if it got too slow, the rotors allow the Osprey to fly like a helicopter, permitting it to maneuver and land vertically into a small space.
Because the rotors are so large, the Osprey was not designed to take off with the rotors fully down in airplane mode position.
The Osprey, however, can take off and land with the rotors tilted partially forward from 90 to 60 degrees from the vertical, called a short takeoff or a stow. A stow requires less power than a takeoff to a hover. The nacelle angle chosen for a stow is a function of the mission's requirements, aircraft gross weight, and ambient conditions. For the same reasons, mission requirements, gross weight, terrain, and weather conditions, the Osprey can make roll-on landings, or ROLs, with the rotors similarly tilted partially forward from 90 to 75 degrees from the vertical position.
The Osprey has a unique designation as a tilt-rotor. It has the ability to tilt its rotors and nacelles from the vertical position like a helicopter to the horizontal position like an airplane.